for a given function. Kind of the first step into the world of antiderivatives and how I could describe the family of antiderivatives for a given function. So remember all of our work from first semester on the derivative, how to find the derivative of a given function. We're going to start thinking about it the exact opposite. An antiderivative is just the exact opposite of a derivative. It's just the exact inverse of a derivative. If I take the derivative of an antiderivative, it cancels out the original function. And vice versa, if I take the antiderivative of a derivative, it cancels out the original function. Kind of the precise mathematical textbook definition, what I have for you here on the board to get started with. An antiderivative is a given function denoted by capital F. On some given interval I, if capital F prime of x equals f of x for all x on interval I. What I was just talking about. If I take the derivative, this prime notation, if I take So let's take a couple of quick, easy practice antiderivatives. Find antiderivatives for these two functions. I want to think about what equation, what function has the derivative of 2x. What function has the derivative of 2x? Squared. If you take the derivative of x squared, what do you get? 2x. So capital F, giving the antiderivative, would be x squared. Anyone think of a different one? Besides just x squared.
X squared plus any constant.
So x squared plus 2. X squared plus 5. We'll talk about how to label those here in just a second. Okay, let's try a trig function. We just did an algebraic function. Try a trig function. What is the antiderivative for f of x equals cosine x? What function? Sine x minus 8. Sine x plus 13. It doesn't matter what you add or subtract on the end, because if I take the derivative of any constant, it should always be 0. Right? Derivative of sine x produces the cosine x, and the derivative of constant just cancels itself out to nothing, out to 0. All right. So let's talk about some more notation and how we describe this infinite set of antiderivatives for a given function. On the middle part of the board. This notation here is the integral sum. The integral of f of x dx. This dx signifies the variable of integration. What am I taking the antiderivative in terms of? It could be dx, it could be d theta, it could be dy. It's whatever variable your function f of x is written in terms of. What is the antiderivative? What is the indefinite integral of f of x dx? Those mean the same thing. Antiderivative and indefinite integral given by this notation here. Find the antiderivative of f of x. What function has a derivative given by f of x. We use capital F of x to describe that family of antiderivatives. And we've also talked about how that could be any constant on the end, right? Because does the constant on the end really matter? If I take the derivative of any constant, it's always going to be 0. So it doesn't matter what you have on the end. It could be any infinite number of constants. So we describe the family of antiderivatives by first saying what function, and then putting a plus c on the end. What is the antiderivative, capital F of x? Plus c to describe the entire set of antiderivatives. Capital F of x plus c describes the entire set, or the entire family of antiderivatives. In other words, for some function f of x. That capital F of x plus c is otherwise known as the general solution. Because generally speaking, c could be anything. Sometimes you might hear this called the general solution. Generally speaking, c could be anything and it would still have the same derivative. C could be any constant. A couple other properties of antiderivatives. The integral of capital F prime of x dx equals f of x plus c, capital F of x plus c. You take the integral of a derivative, what's going to happen? I take the derivative and the antiderivative at the same time. Cancels itself out to the original function, right? Those basically undo each other. Similarly, d dx, the derivative of the integral of f of x dx with respect to x, well, if I take the derivative and the integral at the same time, cancels itself out again to the original function. Okay, let's practice some other antiderivatives. Algebraic functions, radical functions, rational functions, trigonometric functions, etc. What is the integral or antiderivative of 6x dx? When you take the derivative, what do you have to do to the power? Put it in front, and then the new exponent is always just subtracted by 1, right? The new exponent, when I take the derivative of some algebraic function, is just 1 less than what it was before, right? Well, now reverse that. Rather than subtracting 1 from the exponent to find the antiderivative, I would have to add 1. So I know my antiderivative has to be in terms of x squared, right? So that the derivative of that would give me the linear function x. If I take the derivative of x squared, does it make 6x? No, so I have to kind of play around with that coefficient out in front. What constant should I put in front of the x squared so that it gives me the right derivative? Second, Caitlin? 3. The derivative of x squared is 2x. I want the derivative of my antiderivative to be 6x. So put a 3 on. What's the derivative of 3x squared now? Does it give me the right 6x that I need? Right. Don't forget to write the entire set of antiderivatives by putting a plus c on the entire set of antiderivatives, the entire general solution, 3x squared plus any constant c. Usually when I do antiderivatives, I like to think about what's it in terms of. I know if I start with a linear function, it has to be an x squared for the antiderivative. And then just play around with that coefficient out in front so that it gives you the right derivative when you want to go back and check your work. Okay? If I take the derivative of 3x squared plus c, should I just get back to where I started? The derivative of the antiderivative, the derivative of the antiderivative, or the integral, just gets me back to where I started the original function using this property. All right, what is the antiderivative of 4x to the 5th dx? That will be x to what power? It's in terms of x to what power? You gotta bump it up now, not subtract it. You gotta bump it up to x to the 6th. So it's gonna be in terms of x to the 6th. I wanna rig it with the correct coefficient out in front so that when I take the derivative, it gets me back to 4x to the 5th. Right now, the derivative of x to the 6th would be 6x to the 5th. What's the correct coefficient out in front that's going to allow me to get the job done? What's that? 2/3. I want to know what constant times 6 makes 4? 4 is what part of 6? So that would be like 2/3, right? Yeah. Plus C. Kind of generally, if you want the general formula, the antiderivative of constant a times x to the nth dx would be equal to a divided by n plus 1 times x to the n plus 1 plus c. That would be the formula for the antiderivative of ax to the nth. I use it sometimes, but for the most part, I just kind of double check my work by getting back to the original equation when I take the derivative of this. What constant out in front gives me the appropriate constant back in the original function once I take the derivative. Want to use the formula for the antiderivative over here? You sure can. Of course, you can check your work by using this function, using this formula. Let a be given by 4. 4 divided by n plus 1. Well, if n is 5, that'd be 5 plus 1, or 6, times x to the n plus 1, so x to the 6th, plus c. Does 4, 6 reduce down to 2/3? Yeah. Here's kind of the general formula if you want to apply it. I just kind of think to myself, all right, what constant do I have to have out in front so that when I take the derivative, it produces what I started with? Now let's see here. Try negative 3x squared. We're all a little bit different. This is our first one with negatives. It's in terms of x to what power? X to the 3rd. Well, the derivative of x to the 3rd is 3x squared. I want negative 3x squared. So what coefficient needs to be out in front? Negative x cubed plus c. Nice thing about antiderivatives is you can always check your work by taking the derivative of what you just anti-differentiated. If I take the derivative of my antiderivative, the derivative of negative x to the 3rd plus c, it's negative 3 squared. I take the derivative of my answer, I get back to the starting point, negative 3x squared. All right, let's try some more. 1 over x to the 3rd. How can I rewrite that? All right. X to the negative 3rd dx. Here's where people make a mistake. That's x to what power in terms of x to what power for the antiderivative? Be careful with the negatives. What's 1 more than negative 3? Negative 2. Not negative 4, it's negative 2. Negative 4 is less than negative 3. I'm going to bump it up. I'm going to use a negative 2 as my exponent. Okay. What coefficient has to be out front? The derivative of x to the negative second would be negative 2x to the negative third. I want it to be 1x to the negative third. So what constant is going to get me there for my antiderivative? Is it 1/2 or negative 1/2?
Yeah, negative 1/2.
Negative 1/2. Let's double check that here. Forget the plus c on the end. For the entire set of all antiderivatives, the entire general solution. See, the derivative of x to the negative second would be negative 2x to the negative third. Negative 2x to the negative third times negative 1/2. Yeah, that cancels back out to 1. 1x to the negative third. Clean this up, get rid of the negative exponent. Negative 1 over 2x squared plus c. For our radical function now, we did a rational one. Let's try a radical function. The square root of x is x to what power? 1/2. What's the antiderivative of x to the 1/2? My new exponent needs to be what? What's 1 more than 1/2? 1 1/2. How about an improper fraction? Let's keep it improper rather than a mixed 3/2. Okay. So it's going to be x to the 3/2. It's going to be in terms of x to the 3/2. But I still don't have quite the right antiderivative, because if I take the derivative of x to the 3/2, it's 3/2 x to the 1/2. I want it to be 1x to the 1/2. So what multiplier do I need out in front to produce the right antiderivative? Think reciprocal. Right now it's 3/2. I want it to be 1. What do I multiply by 3/2 to change it back into 1? 2/3. Plus c on the end. The antiderivative of x to the 3/2 would be 3/2 x to the 1/2. When I multiply that 3/2 times 2/3, it cancels it back out to 1x to the 1/2. Okay, try some trig functions. Rational radical now a trig function. What is the antiderivative of 2 sine x? What trig function would this be in terms of? Cosine. Okay, so I know it's got to be in terms of cosine. Sines and cosines go together. What's the derivative of cosine x?
Negative sine.
Negative sine x. So right now I don't match it, right? What constant, what coefficient out in front gets me back to 2 sine x? If right now the derivative of cosine x would be negative sine x. Negative 2. All right, could you guys grab your formula sheet for a minute? I know we haven't talked about those in a while, because it's been a minute since we've done some derivatives and antiderivatives. Let's see here, formula sheet would be derivatives and integrals right here. Kind of some ones to keep in mind as we start working our way through. A couple of different properties to keep in mind on some antiderivative formulas on the bottom half. I've got the constant multiple rule for number 1 and the sum and difference rule here for line number 2. The integral or antiderivative of some constant times a function f of u du. I can take that constant, I can pull it out in front. Number 2, the antiderivative or indefinite integral of the sum or difference of two functions, f of u plus or minus g of u du. We separate those into two different integrals, two different antiderivatives. The integral of f of u du plus or minus the integral of g of u du. Let's see here. Number 3, we've done this one here. The integral of du equals u plus c. What do I have to take the derivative of so that it just gets me back down to 1? What function has a derivative of 1? X, or in this case, it's in terms of u, right? So the derivative of x is 1. So the antiderivative of 1 would be x. Let's see, we've done line numbers 6 and 7. The antiderivative of sine x dx is negative cosine x plus c. Line number 7, the antiderivative of cosine x is sine x plus c. Well, why would that make sense? What's the derivative of sine? So the antiderivative of cosine has to be sine. What's the derivative of cosine? Negative sine. So the antiderivative of sine would be negative cosine. What's the antiderivative of sine? Negative cosine. We just put it 2 out front. Okay, let me give you guys one more to try. Let's put one more on the bottom here. I'll keep it algebraic for you. What is the antiderivative or indefinite integral of 8x to the 9th plus x plus 5 dx? Once again, just go term by term. Antiderivative of term 1, 8x to the 9th. Antiderivative of x, term 2. Antiderivative of 5, term 3, and then just put them all together. This plus this plus this plus c. Take the integral of 8x to the 9th, take the integral of x, take the integral of 5, and put it all together. All right. What should x to the 9th become for its antiderivative? And other direction, bump it up. X to the 10th. The derivative of x to the 10th is 10x to the 9th, so I got the x to the 9th part right, but I need to make the 8. 10 times what makes 8? 4/5. The derivative of x to the 10th is 10x to the 9th. Take the 4/5 times 10, and now we have 8. 4/5 to 10 is 8. All right, now I have the next term. How about x? The antiderivative of x is in terms of what? It'd be x to the 2nd. Derivative of x squared is 2x. I want just 1x. So what constant do I have to have out in front? What fraction? 2 times what makes 1? It'd be a half. So 1/2 x squared. Next one, what is the antiderivative of 5? What function has a derivative of 5, in other words? 5x. Don't forget what on the end? Plus c, because there's an infinite set of antiderivatives for any given function. C could be any constant. It would still produce the original. It would still produce the original function by taking the derivative. All right, grab your laptops. Let's get on to Schoology. I'll talk about plan for the next day or two.